All right, we are going to get oriented to R because it is so powerful and it can do as little or as much as you want it to do, which it can do a lot. So when you open R for the first time, it will have 3 sub-panels or 3 windows within it. There's the console, which is when you first open it the first time, it's the biggest one, and then it'll have 2 other ones that have tabs in them. And I kind of call them, you know, for lack of a better word, the few tab panel and the many tab panel, based on the one that only has 3 tabs and the one that has 5 tabs. So pointing out some things. When you look in the console, the very first line in the console will tell you which version of R you're using on your machine. And each version of R has a number, 3.5.1, 4.0.0, and it will say the date of the release, but it also has a name for the release. And this one was Feather Spray. Which one are we on today? Which one did we download?
I have Arbor Day on mine.
Arbor Day? Is that 4.0.0?
Yeah.
Each of these names comes from a Peanuts cartoon with Snoopy and Charlie Brown. So this one is Arbor Day. I don't know which cartoon comic strip it's referring to, but they always have one. So that's what ours says. Now you'll notice mine is kind of this black and gray and navy blue coloring. Yours, when you start RStudio, probably looks like this one is white. We're going to change that. So before we do that, so if everyone, you can either watch or you can follow along, whichever one's easier for you. This recording will be posted on YouTube, which I just wanted to show you our YouTube channel. So I'm going into the playlists. I put in the announcement the link to the video, but our in-class lecture from before is right here. And I'm gonna pause it. But in the underneath, when you go to view it in YouTube, if you click show more, I've gone through and put all the timestamps for everything in that, because it was what, a 2.5+ hour recording. So you could, if you wanted, you're like, oh man, I know that we talked about this in the class, I don't remember, I don't want to watch the whole recording. You can go and like skim through here and say, I need to skip to about 58 minutes and then rewatch that part. So I will try to do this when I record in Zoom. So it's a 2.5 hour recording. Then Zoom has to process the recording to an MP4. And then I have to upload the recording to YouTube. And then YouTube has to process it. So each of those things can take like an hour, depending on internet speed, and putting this in. So sometimes when we're done with class, it might not be till like midnight before it's live, but I will try to get those posted on YouTube as fast as I can.
Thank you. That's a lot of work. Thank you.
I think it's worth it. If you, so this is on the playlists. So this is Stats Foundations in-class 2020 summer. I have my in-class for last semester. Oh, let's see, go to the, so here are all that work. Sometimes it doesn't work. Here are all the recordings from last semester when I taught the same course. So if you wanted to read ahead, these are, I don't know that I have all the, I wasn't doing the timestamps on all of those back then though. But it's interesting to me, this one has 25 views. I only had, I think, 12 people in the class. So on average, people watch these twice, or at least started to watch some part of it. I think it's really good pedagogy to have those for review later. I love having that for classes I teach. Okay, so R, opening R. Anyway, so I say, if you want to follow along, just watch this, and then you can try it later, or you want to try it while we're going. We will have kind of a fast speed though. So if you do have questions, stop me, but we will be going kind of fast. So when you open R the first time, this is not exactly what yours will look like. So let's make yours look like mine. The reason that I like to switch this up is I spend on average 8 hours a day staring at the computer. And when you have black text on a white field, a white screen, it strains your eyes after that long. It's a lot easier on your eyes if you have white text on a dark background. And so to do that, this is the process. So in our studio, I've just launched our studio. Across the top menu at the top, right before the last word help, I'm going to go to tools. And the last thing on the tools menu is the global options. And there's a lot of things in here that I like to change the first time I install our studio on a new machine. Now, the good news is after this, when you update our studio, it will keep this all the same. It remembers you're changing your global options. So the first thing I'm going to come down to is the appearance. And so you can change the appearance. This is the color scheme. It doesn't change how it works, it just changed the color scheme. So the first thing is the theme. I like the modern theme. Again, none of this changes how anything works. If you like a different color scheme, go for it. The modern makes it darker around the edges. You can zoom. So I'm going to turn this up a little bit since I'm teaching to 125%. If you have a small screen and weak eyes, or if you have a huge screen, you can adjust this. You can choose your font that you want it to show, the font size. And then after that, it has editor theme. And you can clip along these to choose. And I change my favorite theme all the time. So generally, I like a darker background, but these different themes highlight with stronger colors different things. So if I'm programming for a package, I might want the parentheses and the curly brackets to really be strong. So I might choose the chaos. But if I'm doing data manipulation, I tend to like the cobalt. It does not matter. Just know that if I'm going to be using the cobalt, and if you want yours to look identical to mine, choose cobalt. If you choose something else, that's fine. Your colors might not match mine though. So if you're okay with that, go for it. I'm going to use cobalt today and probably all semester. I'll keep it the same. Okay, so that's the appearance, that's the coloring. The next one down on our list of options is the pane layout. So when you open our studio the first time, you're only seeing 3 of the potential 4 panes. There is a 4th pane that doesn't come up. The 4th pane is your syntax, your code. You know, started writing code. Yeah.
Sarah, sorry, I got lost. Do you just click OK after you choose cobalt?
I'm going to change several more things, and then at the end, I'll click OK on all of it.
So where did you go to next then?
So on the left-hand side, we were on the appearance section. I'm going to go to the next one, the pane layout.
Thank you.
Yep. So right now, yours will be different than mine. So I like my console to be on the upper right-hand side. So these are all drop-down menus, and you can choose each of those 4 things. So if you change it will swap with whatever you want to change it to. I like my source to be in my upper left and my console to be in my upper right. If you want to match me, that's what I'm going to be using. I like to have the many tab window, that's the environment and the history, in the lower left, because I hardly ever look at it, and I can shrink it away. And then in the lower right, I like the one that has files, plots, packages, and the help menu. So that's the pane layout that I prefer. And again, you can use whatever you want. That's what will match mine. Okay. So that was the appearance and the pane layout. There's a third thing I want us all to change that will make your life simpler. And it's above that, it's the second option on the left-hand menu on the options. It's code in the code section. Is it the code section? No, it's not the code section. Where is it? Let's see. Oh, it's in general. It's in the top one, general. There we go. It's in the general section. So yours might look different than mine. In my general section, at the top, it's listing my R version. Is that missing on yours? Right here, this where it says R version in mine? Do some of you have that? This won't always show up if you only have one version of R on your machine. So you can have, I've got lots of versions of R on my machine because I never delete the old ones. And so I update it. So I've got R 3.6, 4.0. I bet I could come down here. Let's see, 3.51, 3.52. I've got lots of versions because I update it about once a semester. By default, it's going to use the newest version of R, which is what you want. That's what that is. The thing I want us all to change is about in the midway down. It says save workspace to r.r data on exit. Click never. You don't want this. This will screw you up if you're working on more than one project. If you have multiple homeworks going on in your life, this will screw you up. Never save the R data on exit. Never, never, never. By default, I think it's on ask. When you probably started, it said ask. And that means that every time you go to log off, it's going to ask you this question. And your answer is no. So just put never. So never save your workspace. If you only ever have one thing that's going on in your life that you're using R for, that might be okay, but no. Okay. So we changed that one in general, pane layout, appearance. Let's push OK. And then yours should look like mine. Yeah, we're looking good. Okay. So that's how we get it to look the same. Now, there's some nice things about RStudio. I used SAS for many, many, many years because I did my master's degree in SAS. And then my first job, I was introduced to SPSS because that's what my employer wanted me to use. And I used that for a long, long time. And when R, at that time, people were nervous about R because it was free. And they said things like, oh, how do you get help if you're not paying for it? The answer is very well. I have had, with software, all softwares, things happen. You have questions. Things don't work how you expect them to or correctly. In my history, there have been over a dozen times I've tried to contact SPSS's help about questions and errors in software. At least half the time I've never gotten a response, and the average response time has been a week or 3. In R, I have had about a dozen times I've had a question about a package and how it worked or a potential error. Every single time, 100% of the time, I've gotten a response from the package maintainer, and often within an hour or 2, almost always within 48 hours. So, big bonus for R is the help menu. You find the help menu in the many tabs panel, which we've now put in the lower right hand. There's a tab that says help. And let's see, let me go to the home. So you'll have a help menu. I'll be showing you how to use this. It's grand. The other thing that's very helpful is at the top of your screen on the menu, the last word is help. RStudio has integrated something about halfway down that is called cheat sheets. How does this sound to you guys? Cheat sheets. Love it. So we're going to go to the first cheat sheet, which is the RStudio IDE cheat sheet. And when you click on any of those, it opens it up in your web browser. And mine always tries to do Internet Explorer, whatever they call it now, and it always I have to say yes. So these are always 2-sided PDFs, like a piece of, and I used to print these out and I pasted them on my wall next to my computer to refer to all of these. And then I used to print them out and laminate them and hand it out to all my students, but then they kept updating them. So I stopped doing that. But these are really great references for the second page of this one has a bunch of keystrokes, hot keystrokes. I will introduce you to a couple of these through the semesters that I find really helpful, but there's more than you want to know there. The next one, let's go back to, so it's help and then down to cheat sheets. The R Markdown cheat sheet is towards the bottom. R Markdown cheat sheet. Yes, I want to open it every time it asks me. All right. So this one's really helpful on the second page. So what would be the back if you printed it? Let's see, I'm going to come over here. There we go. It has Pandoc, Markdown, what you would write with syntax on the left, and what it creates is shown on the right when you knit it to a PDF. So plain text, you just type it and you get plain text. If you want the end of a line, you put 2 spaces at the end, it knows that's the end of a line. If you want to start a new paragraph, you put 2 spaces at the end of a line and enter, and it will be a new paragraph. If you want something to be italics, I said this before, you surround that, whatever you want to be italicized with, an asterisk at the beginning and the end. If you want it to be bold, you surround it with double asterisks. So these are some of the most common things that we want to format. If you want to have a block quote, you put the sideways caret, the greater than symbol, and it will make a block quote in your PDF document when you knit it. You can do formulas. I showed you about a pound or an ampersand does a header for the section, and a double pound, a double ampersand will make you a subheading, and on down to 6 pounds. We can also do bulleted lists. If you wanted to do a bulleted list, you put an asterisk, space, and then write stuff, and then another asterisk, space, and write stuff, and that will make a bulleted list. And you can have bullets with sub-bullets and sub-sub-bullets. So over on the left-hand side, it tells you what you would type in R, and then on the right side, it shows you what it will look like in your finished PDF. You don't have to do a lot of this stuff, but there it is for you if you wanted to know how to do things like that. So there's some fun cheat sheets there. Those are handy to figure out how to do things in R. Let's see, we did those, swapped those, we changed the color. Okay. All right. So this is what I'm showing you right now on my screen is the Encyclopedia. Remember, to get to the Encyclopedia, it's the 3rd hexagon on our Canvas page. When you click on that, it will take you to the landing page of the Encyclopedia. Then you have to go to volume links, and we're in the software volume. And now I'm down here under installing packages. So now we've installed R in our studio and tech. We've gotten it to look the same. Now, I talked about before, when you get a new cell phone, you get the bare bones packages, and you need to go to the App Store to get more apps. Apps, not packages. In R, we call them packages instead of apps. We need to go get more than the bare bones, and we're going to do that right now. So packages are basically a zipped folder of files, and those have things like data sets in them, functions that can do things, and their help pages. You can get packages from a lot of different sources. CRAN, the Comprehensive Archival Network, is free and integrated in our studio. GitHub is also another place. That's where the Dissertate USU lives. Other packages have their developmental versions there. Bioconductor has a lot of things for bioinformatics, but anyone can make a package. You just zip together files that for R, and then you have a package. So we are going to go to CRAN and get some core packages that you're going to need for this class. And this list right here in red is the list of packages you need for this class, and then some. These are the handy dandy packages I use most often that I see you guys needing to use most often. So down below this big red useful package list, I have each of those packages with a link, the name, description of what it does, and a link to this website that describes it. But for today, we're just going to take and highlight this big red list, copy it, so Control-C or Command-C, or you can right-click and copy. We want to have this copied, and we're going to go into RStudio, and we're going to install them all at the same time. And this should get us all ready for the whole class. So in RStudio, the quickest way to install packages is with the Package tab. And it's in the lower right-hand corner, next to the Help tab, is the Packages tab. When you click on it, you'll see a lot of stuff underneath it. These are the packages that came with barebone R's. I've got a lot more on my machine, so don't compare ours. But on the Packages tab, we're going to click the button that says Install. Can everyone find the Install button? Thumbs up if you've been able to find it. Laura, are you good? Hillary, good? Okay. So when you click the Install button, you'll have this little window pop up. By default, it's going to look in CRAN, which is where we want, and it's going to install them in some place on your computer. Leave it the default. This is why we left everything the default before. This checkbox says Install Dependencies. You want that checked. Then you're going to click on that empty box, and this is where you're going to paste that whole long list of all those packages. They have to be separated with a comma or a space is all. Capitalization and spelling matters, but you just paste them all in there. And we're going to push the Install button. This is going to effectively go to CRAN, which is like our app store, and it's going to get all these files and through the internet and bring them down and store them on your hard drive. So it has to go, this is called installing a package. You only install a package once per computer. This is getting it from CRAN and putting it on your computer. We don't want to store anything more than we need because we don't want to fill up our whole hard drive. Installing happens once. Now to use these, we have to check them out of our library of all packages with a library command. But for right now, we're just installing them down to our machine. They won't be active in RAM until we ask them to be. Melissa.
Oh, sorry.
Oh, Sam, go ahead and then I'll ask after.
Mine didn't do that. It gave me like a, do you really want to do this, or warning to install.
Okay, if it asks you something like that, say yes.
And it doesn't give me a place to say yes, though.
Okay, so sometimes, and I think it's mostly Mac that does this, you have to use your keyboard and hit the Y key for yes, and then hit enter. I think sometimes on Macs it asks you if you want like the binaries or something like that. Yeah, you have to hit the key Y and then hit the enter key. And then did it start going?
Yes.
Yeah.
I hit what? Plus Y? Command Y maybe?
No, just the Y key. Oh, click over in your console.
Oh, I was in the wrong place. Sorry. Got it.
Got it. Good.
I was trying to get Zoom to do it for me. Okay.
Oh, no. Zoom doesn't know what that means.
Sarah's, okay, sorry. Actually, I'm not finding the link where we packages.
So it's in, so to get there, it's the Encyclopedia.
Okay.
So you click on the Encyclopedia. Then in the upper right-hand corner, click Volume Links.
Okay.
And then click on the red Volume 0 Software.
Okay.
And then it's Chapter 3, Installing Packages. Scroll down.
And then just highlight the package list.
Just starting with Tidyverse on down.
Perfect. And then just copy and paste that into the install.
Copy and paste that into your install buttons place.
Okay. Perfect. Thank you.
Yep. So these are zip files. So it had to download them to your machine, and then it has to like unpack them and check them to make sure that they weren't corrupt or something. So this takes a minute because we're doing a lot of them. And a lot of those packages are dependent on or use bits from other packages. And so even though our list might have 50, you might be in the process of installing 150. So what in here, most of these packages should be enough to do the next class or two. There's stuff in here that does regression. There's stuff for multi-level modeling, for SEM, for random forests, survival analysis. There's the book down, blog down, and the slides. There's a lot of great stuff here. I didn't try to overwhelm you, but anything I thought you might use in your basic stats classes that would come in handy. You know you'll be done when that console window comes up with, we call it the, it's like the greater than symbol, or what do we call it? It's like your cursor is ready for new information. Mine is finished. Notice I have my little caret, my greater than caret symbol. That's how I know I'm done. And I'm on campus, so I have a pretty fast internet connection. I'm assuming most of yours are probably still going. So if you want to know what any of these do, there's one that's called YAR. It's the Pirate's Guide to R. And here, most of these have a website that goes with them. This one has a free book that you can download. It's a really great one, actually. But it has some useful things in it. It's not just cute. We are going to use the furniture package a lot in this class, especially in these first few chapters. Furniture is a package that's written by Tyson Barrett, across the hall from me. He called it furniture because it has a lot of table functions for creating the tables that we all often make a lot of the time. It makes it automatically for us. Like in chapter 2, it talked about those frequency distribution tables with the frequency, the cumulative frequency, the relative frequency, the cumulative relative frequency, automates it. Table 1, that's usually a descriptive table of your sample, usually stratified by different subgroups. It automates that. He also has a washer in here. I don't use it very much. So that's where the name came from. We're going to use this one today, this furniture package. But most every R package will have a website out there that tells you how to use it and options and documentation. So while we're here, I'm going to show you something cool about R. So one thing with software is you want to, when you're writing this up for publication for your thesis, dissertation, or manuscript, you need to be able to cite your packages. So usually we can just say we're using R, but you need a citation to go with R. So if you go into your console, now yours are busy, so just let them be, but watch mine. I'm going to type citation and open parentheses and hit enter. I'm going to shrink this down. It says to cite R in a publication, use, and here is the citation you would put in your bibliography for using R. And it has it as a BibTeX entry if you're using a BibTeX program, which probably not, but it's there. So anytime you type citation and then in parentheses, if you leave them blank, it will give you the generic R citation. If instead inside those parentheses, you put in quotes the name of a package,
Furniture.
it will give you the citation specific to that package. So if you're using the furniture package, there is the citation. We are also going to use later on the AFEX package, AFEX, to do our ANOVA models. Oh, I spelled it wrong. Spelling matters, which is hard when you're dyslexic. There's the citation for the AFEX package. So any package you're using in R, you can easily get the citation to go with it, which is handy. The other thing is in this packages tab, it has a little magnifying glass. You can type the name or start typing the name of a package, and you can click on that and you get some information about the package. You get all the help pages. There has to be a help page for every function or command in the package, how to use it, what it does, details about it. And you also will get an overall generic description file for the package. And they're all in this crazy old DOS looking file. Every package on CRAN has to be vetted. It has to have no errors. It has to have the authors, and it has to have a main author that is maintaining the package and how you contact them. This is how, if you have a problem with the package, you email the author of the package or the package maintainer to ask questions. And the R community is fabulous about answering questions and getting back to you, I found. A lot better than the paid companies, SAS and SPSS. So I'm going to come back out here. So furniture has these functions. So today we're going to learn table F. Table F, the F is for frequency. Table F makes a frequency table. I can also, if I know that it's table F, I can go in my console and type a question mark and then say table F. And when I hit enter, oh, it says no documentation. I haven't loaded any package. So I'm going to say furniture table F. So in R, I jumped ahead of myself there. In R, everyone has a different set of packages, and any package can have any number of functions, and everyone names their stuff whatever they want to. So this is a pro and a con of having open source. Tyson named one of his functions table F. Somebody else could have a package and they might have a function and they call it table F. How do you know which table F function you want to use? So the way we do it in R is we put first the name of the package and then the name of the function, and we separate them with 2 colons. So here, and I question mark because I want to look up the help page, but I said furniture table 1. Furniture is the name of the package. Table F is the function inside of that package. So I'm very obvious and very clear which function I want from which package. Now that I've specified it and I hit, so I did question mark, furniture table F and hit enter, it brings up my help page for the table F function. This one's really, really basic, so its help page is very, very short. Every help page is laid out the same. At the first line, it says the name of the function, which here is table F, and then in curly brackets, it says the name of the package, furniture. And then in the corner, it says R documentation. And it has, you have to name it, so this does a frequency table. Next comes a description. This gives an in-depth frequency counts and percentages. Then it tells us how we're going to use it. In R, to use a function, we state which function, and then we have parentheses. Inside the parentheses, we put some options. So we're going to give it some data, and so the first thing we need to give it is the data set. Then X, down here it tells us X is a bare variable name, so we want to say which variable in our data set we want to do the table for. If it has a lot of values, we can do some of them. And it's going to return to us a table. And so it has some examples down here of how to use it. So I'm just going to, for now, while we're waiting for everyone to finish up, I'm going to highlight the whole example, and I'm going to copy that, and I'm going to paste it up in my console, just for now, and hit enter. Woo.
Does every help thing have an example like this so we can play with it?
Yes.
Awesome.
They should anyway. They're supposed to. So here is an example. So here is a table F. Notice we have values 1 through 4. We have the frequency count. Our book uses an F for that. Then we have the cumulative frequency. Our book uses CF. And then we have the percentage and the cumulative percentage. And this was here, it was just a data that was made up. But this is how we're going to use it. It does this. Now the book in chapter 2 did all this, lots of examples about how to do classes and the midpoints and no, we're gonna let R do this for us. Okay, is everybody's done installing packages? Are we good with installing packages? Okay, so we got packages installed. Okay, so I'm gonna come back to R. Let's see. Okay, so here we'll go back. This is my schematic that I put in the Encyclopedia in chapter 5. This is all I have in chapter 5 pretty much. It's pretty bare right now. So we're going to write an R notebook. This is an RMD file. And when you do this RMD file, we can import data sets, and we can then knit it and export an PDF. That's what we're going to do for class. The good news is you can have your data coming in almost any format. You can use data that's been entered in Excel, data that's been entered in SPSS, SAS, Stata, REDCap, a comma-separated text file. Any of those formats of data can be imported into our RMD file where it's processed, and then we're going to knit to create a final document for class that's a PDF. But I've done it for a website and for HTML slides. You can go to anything. So this is our general process. So in the homework, let's start with the homework. Let's go to, so in Canvas, assignment 1, homework 1, HW1. It was pointed out at the top of the assignment, there were some downloads. There's 2 downloads for the first homework. We're going to do the first homework together. So there's an Excel file, and this is the Excel file that contains Ihno's data set. And there's an RMD file, which is the skeleton for our Chapter 1 homework. So I want you to download both of those to your computer. You click on them, it should download them to your downloads folder, however that works on your computer. Now there is something we need to be careful of. Your data file and your R notebook must be stored in the same folder. They have to live in the same place. For R to be able to import the data has to be stored with the RMD file. So I've downloaded them both, and they've gone to my downloads folder. I highly suggest you don't use your download folder and you don't use your desktop, that you create a folder on your machine to house your homework. Now we're going to use Ihno's data set on all 18 homework assignments. It's the same file every homework assignment. You don't need to re-download it. I will put the link there every time, but you only need it once. So I'm on Windows, so my files that I just downloaded went to my downloads folder. So I want to go get them, and I am going to put them in a new folder, and I'm going to call it class lectures.
Sarah, will R automatically do that, or do we have to specify the folder?
I'm going to show you how to specify the folder.
So yeah, it's not going to just look and see for us?
Well, kind of.
Dang it, can't it read my mind? Come on.
It tries, and it tries to read your mind, and sometimes it does a good job, and sometimes it does not do a good job. So I'm going to show you how to force it to look in the right spot. Okay, so that's the only other thing that's in that volume of the encyclopedia. Where is it? Yeah. So here's our notebook kind of flow, organization flow. So down here at the bottom. All right. So I'm going to go into R. So in R, we're going to open up our skeleton. So we are going to, in R, so we've done the, at the top, we've done the help, we've done tools. The first word is file. So we go to file, open file. So you can go into the open file and search for where you stored the RMD. And it's, let's see, where did I put mine? Class lectures, right there. Chapter 1, assignment R skeleton is what I named it. And you can double click on it and it will open it. You can also go in your file viewer and double click on the name of the assignment, and it should open it in R. It doesn't always, sometimes you have to right click on it and tell it which program to open with. I find that it's easier to just go into R and open it. but here it is. So this is the skeleton for your first assignment. Thumbs up if you were able to open that. Sweet, awesome. Please tell me if you get stuck at any point. Okay, so I like to not have clutter because I get confused. So there's these 4 panels. That's a lot of stuff there. I want to simplify things. So you'll notice each of these 4 quadrants of the panels have these little buttons in the upper right-hand corner for the panel. And those are to shrink and expand each of those sections. I like to shrink the lower left-hand one away. It just confuses me. I like to not see it. That gives me more real estate for my homework file because it can go from the top to the bottom. Okay. And I'm going to leave my console and the help file, all that over on the other side for now. Okay. So let's look at the pieces of our skeleton. The very top part, this is our YAML header. And the way that the computer knows it's the YAML header is there's 3 dashes to start it and 3 dashes to end it. And I've already typed this out. You need to change the author name to your name. So right now I've got a title, a subtitle, and then it says author. So highlight your name and type in.
Keep the quotations?
Keep the quotations, yes. Yeah. In our quotes signify it's text and not numbers. And generally speaking, in all computer speak, names can't have spaces. A space is like a break and on to the next thing. So the quotes keep it all together. Now it says spring 2019. You probably want to change that to summer 2020. You can also change it to May 6th, 2020. You can put it second week in May. You can change it to anything. It's quoted text. So there's no demand on format. You can put whatever you want. So this YAML header, I've got a lot of stuff in between those triple dashes. There are 2 things that must be there or else it doesn't work. You must have a title. Subtitle is optional, author and date are optional, but you have to have a title. The second thing is you have to tell it what to output to. For all of our homework, we're going to output to a PDF document. So you notice PDF document, there's not a space in there, but what do they use instead of a space? The underscore. That's like the cheat way to have a space in something you're not allowed to have a space in. That tells R that when I hit the knit button, I want to make a PDF. Can anyone find the knit button? It's got a ball of yarn with a knitting needle through it. Everyone go ahead and push that. This is where we find out if your LaTeX got installed correctly. You'll notice over where your console used to be, the console tab is pushed back and it's brought forward the R Markdown tab. Now that knit button has a drop down. Don't do the drop down, just hit where the yarn is, the word knit. Did you see what came up on my machine? Did something come up on yours? Did you make a PDF? No. Got yeses, no, no, Laura.
No, I got an error.
Okay, if you got an error here, it's something's going on with your tech. Let's figure that out outside of class since we only have like 45 minutes left. Ish.
Totally cool.
Okay, so notice what I have. Here I have at the top of, we'll look at mine since mine's on screen here. We have the title, the subtitle, the author, and the date in smaller and smaller text. And then it gives us a table of contents, all automated. And it knows how to make the table of contents because where we put a single pound, that's a section. A double pound is a subsection. And it's filled out all the page numbers for us. Not nice. Okay, so I'm going to shrink that down. There's our PDF. This PDF, notice what the name of our PDF is. You see the name up there at the top? It will be exactly the same name of your RMD file, except for it replaces the spaces with dashes, and it's now a .pdf. Where do you guess this is stored at on your computer?
In the same file where everything else is.
Same file where everything else was. Exactly right. Now, if you got an error, try this. You might have gotten an error because it was trying to find Ihno's data set and it didn't know where to look. This frequently happens, especially if you have multiple files going on. So up across the top menu, everyone do this so you know how to do it in case you have this mistake in the future. Go to Session. The word is Session. Then about midway down, Set Working Directory. The working directory is where R is going to look for all your data sets and where it's going to store your knitted PDFs. So Session, Set Working Directory, to source file location. Your source file is your RMD, your R code file. You want it to be there. So Session, Set Working Directory, to source file location, and click on that. You'll notice in your console, it will have typed out set WD, a shortcut for Set Working Directory, and then it will have quoted the location on your computer. And that tilde wave is just like everything that comes before it. It's a shortcut. Everyone's will look different depending on where you saved your R Markdown file. Another way to check this that I find myself doing because I have lots of stuff going on and my R gets confused is on the Files tab below your console. So we've done the Help tab, the Packages tab, now we're going to do the Files tab. Go over to the gear that says More. File tab, gear that says More. And we are going to click on the Go to Working Directory. So Files, the gear that says More, Go to Working Directory. You should see, among other things, depending on your computer, the RMD file and the Ihno dataset XLS. And if you were able to correctly knit, you'll also see the PDF. If you had an error before, try going and knitting your notebook again and seeing if it'll work this time. Did it work, Laura?
So I think what happened was when I installed my packages, it came to a point where it asked like yes, no, or cancel. And I didn't respond to that. And so it didn't install all of the packages.
Okay, we can work on that out after class then.
Okay.
Yeah, we'll get you fixed up. Anyone else? Did that fix anyone else's? Leah?
I'm still having issues. It says the latex failed to compile. So
Okay, we'll need to check your, and Kimberly, you're the, yeah. We'll take care of that after class. There's a bunch of reasons that can happen. This is like our test to make sure everyone's computers are ready to go. Okay. I want us to look at the different parts of this file. So the YAML header is that triple dashes at the top. That's the only place that happens, is at the very top of your file. There's some other options I've set here. We're going to just ignore them for the most part right now. This LaTeX engine is about LaTeX and it's confusing to me even. TOC stands for table of contents. So this is where you say yes or no, true or false, whether you want it to make a table of contents, and then the depth, 2, 3, 4 levels deep that you want the table of contents. And if you want those sections and subsections to be numbered, that's what that's about. Okay, so the first section I have here is preparation, and the first subsection in there is packages. Now this is kind of handy. Our studio's added this nice thing. In our RMD window, if you go to its upper right-hand corner where there was the grow and shrink buttons, in the very corner there's a button that has a bunch of lines that are kind of on top of each other. If you click that, it will give you an outline of everything that had hashtags, single, double, triple, quadruple hashtags. This is like a mini table of contents, and it is clickable. So if I want to go down to question C1, I can click on that and it will jump to that part in my R file. I can skip down to question C5A. This is all clickable in my little outline format. So it's really nice when you're working on the homework and you want to go back and forth and you're scrolling through a long file.
So these are
Yeah.
all of our homework assignments for the class, right? Every chapter.
Every chapter will have one of these skeletons that I've already written for you.
Okay.
Yes. So, yes, true. You'll also notice on the farthest left-hand side of your window, each of those lines has a number. So I can say, go to line 21. Now these line numbers will change when you type stuff in. They'll adjust, but that helps us kind of finding our place around in this very long document because it goes on and on and on and on and on. Okay, so the first thing I've done is I have a code chunk. Now, how do I know this is an R code chunk? The triple ticks we talked about. Where does that tick key, the back tick key, live on our keyboard?
Below escape.
By the escape key, right under the escape key. So a triple tick starts and ends a code chunk. Then in curly brackets, we have to say that it's R code with the R code language. And I'm calling this, naming this chunk libraries. So we downloaded a ton of packages to our computer. When we installed those, it put them on our hard drive. But it doesn't make them all active every time, or else it would just bog down your RAM, your active memory on your computer. So you have to tell R which of those packages, other than the basebone default ones, that you want to be active or live. The language library is like an old, like, you know, we used to do cards in computers. You had the punch cards to read data into computers. SPSS still uses cards, that word, to enter data, even though nobody's used a punch card in my lifetime, pretty much. So we're still using the word library. You can think of all those packages as being in a library, and we're going to use the library word to check them out and make them active. So for this assignment, we're going to check out the package tidyverse and the package readxl. Readxl is a package that reads in Excel data. So those are this is telling our computer which packages we want to be active besides the basebone default ones. Now you'll notice that the code chunk, the background color is a little different than the rest of the color. In my Cobalt, am I using Cobalt? I forget which one I chose. It's a lighter dark gray than the regular almost black dark gray. That is an I, tells you that it's a code chunk. In the upper right-hand corner of the code chunk, you'll see 3 little tiny buttons. There's a gear, there's a triangle going down to a green line, and a green sideways triangle. The gear are for some chunk options. I have never used this. You probably won't either. The middle one, if you hover on it, says run all chunks above. We will use that in the future, but the last one is the most helpful. It runs the code or executes the code that's in that chunk. So if you push that, everybody push the play button on that first chunk. You'll see there was a green line over by my line numbers, and it's got some output that's popped up underneath it. We're not going to worry about this output, but it's there. The same thing is duplicated in the console window. We're going to ignore it for now. Then under that, I have this, on line 23 of mine, I have a /clear page. This harkens back to LaTeX. Remember that big manual LaTeX? You don't have to learn, but this is how you put a hard break in, is with the LaTeX code /clear page. So that just does a page break. Now we're going to do in section C, there were some homework questions that wanted you to do some stuff with your data set. Remember, in our textbook, section C is always doing stuff with Ihno's data set. So the first thing we need to do is import the data from the Excel file. Now this is, I call this a homework skeleton because I have prepped it for you, but all these code chunks, look what's in that code chunk on line 40. It's blank. This is where we're gonna do our coding. So fingers ready on the keyboard. And I put some little comments here. It says use the read Excel function in the read Excel package. Now, which order do we put those words? What comes first, the package or the function name? Anyone remember? It's the package name. So I'm going to type into here on line 40, read, and then the letter X and the letter L. That's the package. Notice that some stuff has popped up. RStudio does this autocomplete. It says, do you want read Excel ? And if so, here's a little snippet of the help menu. And it tells you some stuff about it. Yes, that's what we want. And you can click on it, or you can arrow down and enter for all these autocompletes. And then it's like, well, would you like to do any of these things? Well, I want to read, and you start typing. A long time ago when I did base R and we didn't have RStudio, if you made a spelling mistake, you hunted it forever. Autocomplete avoids a lot of that stuff. So we want to use the read XL package and the function read Excel. And then inside here, we need to put in quotes the name of our data set. Now I have the file name sitting over here in my files tab that I can look at. Now, there are 5 mistakes that I can almost guarantee 99% of your errors this semester will be. Ready for the types of mistakes you're going to make? Spelling. Capitalization. Parentheses that don't match up. Every time you have an open parentheses, you've got to have a matching closed parentheses. They have to be partners. Commas and periods. Often I will type the wrong one because they're next door to each other on the keyboard. And the last one are pipes, and we'll talk about that in a second. So in R, in all computer language, spelling matters. In R, capitalization matters. If you've used SPSS and SAS, they ignore capitalization. R does not ignore capitalization. A capital R and a little r are 2 different letters. You gotta have the right capitalization. So now so when you type in the name of the data set, you must capitalize it perfectly. Okay. I have now typed the code to read in Ihno's data set, but it didn't do anything. To make it actually do it, I need to push the run button. So that's the little triangle in the corner of that code chunk. When I push the run button, it will read in the Excel data set because that's what I told it to do. And you see that that output underneath the code chunk is the data set. The first variable is the subject number. The second variable is their gender. The third one is their major. But hang on, what is gender 1?
Probably female.
Female. What is major 1?
No idea.
Right now we don't know. So part of this assignment is to attach labels so that we do know what those mean. Okay. But right now we've just read it in. Now this is all fine and dandy, but let's see, if you come down here, let me clear this out. Right, so here I run it. When you run that code chunk, if you have that bottom environment tab open, it's still blank. When we executed this read Excel, we read the data set in and it printed it out, and that's all. It just printed it out. We can't do anything with it unless we save it as a name so we have a handle to grab it with. So the way that you save things in the global environment in the memory of R is we use this little assignment arrow, and it's the less than symbol and then a dash without a space. They have to be mushed together to make an arrow. And the way we do it is we do it at the beginning of a line. which is a little bit backwards as I would think it should be, but it's the way it works. So this says the name df_0 is being assigned, because the arrow is pointing it to, that name is being assigned this read-in data set. I'm using df0 on purpose. I mean, I could call it Fred and I could call it George, but df is shortcut for data frame, and 0 because it's our starting out. We haven't done anything to it yet. And again, when you name things, you can't have a space in the name, so we're going to put the underscore to kind of glue those things together. So this is our initial data set, df0.
So there's no space between the 0 and the next caret.
There can be. In general, computer doesn't care very much about space. Space is space, but you don't, but we use space for legibility. So I've typed in df_0, so that's all one glued name. Then I'm going to have this assignment arrow. It can't have a space in it, but I'm going to put spaces around the assignment arrow. Once you have that typed in, rerun your code chunk by pushing the play button again. It didn't print it out. But look at the bottom of your window into your global environment, your environment tab. I now have a data set that is named with a handle that I can grab and do stuff with. Down here it says df0 has 100 observations and 18 variables. Now I have actually read in and retained a copy of the data set. It's read in the Excel file. The Excel file is still living in memory in the folder. We don't change the Excel file, but now we've read it in and we have it in R's memory as a data frame. Notice there's a little blue arrow in front, in a circle in front of it. It's teeny. If you click that little blue arrow next to data frame, it will show you the variables and kind of one view of it. I don't think it's a very good view of it. If you double click in that environment tab, df_0, if you double click the name, it will open what is basically a spreadsheet of the data set. So you can view it this way. You cannot manipulate it directly this way like you can with an Excel or an SPSS sheet. So I'm going to close that. But it lives there. Okay, whew, you guys just wrote your first line of R code. How do you feel? Very good. Okay, so when we make an assignment in a code chunk, it does not produce output. We've read our data set in and stored it as df0 with that assignment arrow, but we didn't get any output. So the best way, I just showed you how you can use the tab at the bottom and double click on it. But a better way to view it is in a code chunk to type its name only and run it. So what was the name of the data set? df_0. Spelling, capitalization, all of that perfect. If you run the code chunk with just the name, it will print it back out for you. Now, it doesn't print the entire thing because it would take up a lot of space, but at the bottom, we're told it's only showing us the first rows 1 through 10 out of 100 rows, and it's only showing us 1 through 10 columns of 18 columns. Down at the bottom, we can click through the different pages. This is essentially scrolling down. And then to the so our variable names are subject number, gender, major, After math quiz, there's another arrow, at least on my screen. How many variables you see depends on how big your window is, but there should be a sideways arrow that you can scroll sideways in your data set to see the other variables. Okay. So now we're going to go over some basic commands that are very, very handy with data. It looks like time-wise, we're not going to finish all of chapter 1 and 2, and I'm okay with that. Whatever we don't finish, I will make a recording of and post on YouTube, okay? So I'd rather do half of it really well than all of it really crappy. We're going for quality here. because we will be using these commands for the whole semester. Basically, this homework one is building the first part of every homework file from here on out. Okay, so the first command I'm going to teach you about is called names. So if we go over in our help tab by the little magnifying glass, you can type the word names, and you have to put enter twice to actually have it search. You get the help page for names. Names is a generic command that returns the names of whatever you gave it. For a data set, it gives you the names of the variables. So in this code chunk, we're going to type the function names. Now, I'm not going to bother to put the package name because this is in base R. If you look at the help file, it says names is in the base package. So I don't bother putting the package name if it's in the base bare bones R, because everybody gets that. So I'm putting names, and then functions always have to have parentheses to tell it what it's doing the names of. Here we're going to do the names of df0. And this will give us and when I run that, it will give us the names of all the variables in our data set. Now I want you to look at the names of those variables. I told you capitalization matters. What do you notice about the capitalization on those variable names? The first letter is capitalized of every variable. That's going to be important to know in the future. Okay. So names is our first function we learned. You just learned a command in R, names. Our second command is dim. And a lot of these base commands come back when we were typing everything by hand and didn't have shortcuts and autocorrect, so we made things short. Dims of a data set tells you the dimensions. In math, when we do matrices, we always give the size of a matrix, a grid of numbers, by the number of rows by number of columns. So we're always going to be told the number of rows and then columns. So 100 is how many rows are in our data set. 18 is the number of columns. This is always the good thing to do the first time you have a new data set in R. You want to know how big it is. Is it what you expected? Is something missing? Okay, the next command is also so helpful, is the command glimpse. The command glimpse comes in the tibble package, which is part of the tidyverse. So we're going to say tibble package, T-I-B-B-L-E, double colon to say the function that's in, and the command name is glimpse. And what do we want to take a glimpse of? Our data set, which we call df_0. This is my favorite way to get kind of like a big picture view of a data set. It tells you at the top how many rows and columns, and then you have the names of the variables, the kind of variable it is, and the first values until it runs out. It puts the values until it runs out of space. So the first variable is sub_num. This is the subject's number, their ID number. And it goes from 1 to 100. The second variable is gender. And it looks like it's a whole bunch of ones, and eventually we get a whole bunch of twos. They're sorted by gender right now.
Dr. Schwartz?
Yeah.
You said it says the name and then the type of variable. What does that mean? That's nice.
Yes. This is, you're like reading my mind. This is so awesome. So the type of variable. So that's what's here in this lighter gray with this in the carets here, the sideways greater than less than symbols. All of these variables right now, their type is currently dbl. And it took me a while to figure out what this meant when I first started using R. This stands for double, which made no sense to me until I looked into it. It's computer lingo. It stands for double floating point decimal. Basically, it's a number. It's how computers store numbers. So if it says dbl, it's storing that variable as a number, numeric information. And that's why we see the numbers 1, 2, 3, 4. If it was text, we would have quotes around the value because quotes go for text, and it would say CHR. CHR is for character. In SPSS, they call it a string. In other programs, they'll call it text. Text, string. In R, we call it a character. CHR is for text, anything that's stored as text. DBL is for something that's stored as a number, a double floating point decimal number. What we don't see here, which we want to see, are factor. FCTR, factor. That's what we're going to do next. Next? Yes, that's exactly what we're going to do next. Okay, so this is, from this view, this glimpse of the data set, I can see all the names of my variables, the size or dimensions of my data set, some of the values, and that these are all currently being stored as numbers. Now, there's something in here I want you to also look at. On this math quiz variable, look across, depending on the size of your screen. If you go down over far enough, you'll see something that's not a number. What's not a number? NA. NA is how R stores missing information. NA is not applicable, it's basically missing. So there are some people, there's actually 15 people in this data set who don't have a math quiz score. It's missing. In some programs, they'll use a blank cell in Excel. In SPSS, it uses a period or sysmiss to represent missing data. But in R, missing data is this capital NA. It's not quoted, it's just NA. It's a special thing that means missing. Okay.
How do I scroll over again in this part?
In this part, you can't scroll over. It's just a brief glimpse. And
okay.
So if your text is big, your screen's small, you might not see that NA yet. And it's not a bad thing, it just is. This is just meant to be a kind of an overview look. I just wanted to point that out because that will come up later. Okay, in our textbook, there is an appendix. Let me see. Let's see, where is it? I just had it. This is photocopied out of the back of your textbook in Appendix C. It has what the variable names are in the Excel data set and what they mean. So this is like our data dictionary. So the gender variable is stored as 1s and 2s. 1 is for female, 2 is for male. There is no way to know this unless you have the data dictionary key given to you by whoever made the data set. When you're entering data for your own projects, keep track of this, please, because it is not, 1 does not always mean female and 2 does not always mean male. We could have 0 and 1, they could be in the other order. It's specific to this data set. So what we want to do now is to label the 1s and 2s so they say male and female. And we want to label the majors. And we're going to do this not just as busy work, and we're not doing it because it's nice, but because it will save our bacon down the road. When we make tables and figures and do analysis, it'll be so much better to have those labels attached. And we're not always going back and saying, gender 2, what was that? Major 4, what was that? It's very time saving in the long run. So here I have written out, and notice I have the asterisks, and then I have over a little bit more a plus. This makes a bulleted list with sub bullets when we knit it. Look at the knitted version. Notice in the knitted version, we've got a bulleted list with some sub-bullets. So gender, 1 is female, 2 is male. Now, look at the word gender here. Do you notice the font that gender's in? Notice how it's a slightly different font. I create that by using that backtick before and after at the start and end of the word, and that makes it set aside. We use that to denote code when we're writing stuff, and it like puts it in a different color here. Okay, so now we need to declare these factors. How many factors do we have? Gender, major, reason, experimental condition, and whether or not they drink coffee. So we have 5 of our variables in this data set are currently stored as a number, but really should be a factor. A factor is either a nominal or an ordinal variable. In this case, gender is what? Nominal or ordinal? Pop quiz.
Nominal.
Nominal. Major?
Nominal.
Nominal. There's numbers, but really, why do we put the numbers that way? We could put them in any other order, right?
Right.
Coffee, ordinal.
Coffee or no. Coffee or not. That's a special kind of categorical variable that we sometimes call binary or dichotomous because there's only 2 levels. Is there order there?
No.
No, but there's only 2, so yes. So sometimes, usually with those 2-level variables that are a yes, no, true, false type, we usually use 0s and 1s to code those most often. You don't have to, but that's handy. What about experimental condition? What kind of variable is that? Easy, moderate, difficult, impossible. Is there order?
That's
Gotta be
ordinal.
ordinal.
That is ordinal. Just bringing that up. Okay, so now we need to attach these labels into our data set. Now, this time, I want to keep the original variables that were numbers, and I want a factor version of the variable. And to do that, I am going to create a new variable that is so I'm going to create a new gender variable that is a copy of the original gender variable, but has labels attached to it. So let's see, I got a bunch of stuff here. Okay, so the first thing I want to do is I'm going to start with df0, and I'm going to do something to it. And we're going to use the pipe. The pipe in R is a special symbol that connects steps. So we have a farm, and on our farm we have crops, and crops need water to grow. And so we have to get water from the canal to the crops across the field. How do we move the water? We have irrigation pipes. The pipes have to all connect. What happens if we're missing one of the connections? It doesn't go where we need it to go. So the pipe is how we connect steps. And this is how we can read our code from left to right, from top to bottom. So we're going to start with our data set, and we're going to do something to it. Now here we're only going to do one step to it. The thing we're going to do is we are going to create a new variable that's a labeled version of gender. So we're going to do, oh, it says first we need to rename. Okay, we got 2 things we're going to do. Let's see, starting with the data set we imported, df0, we're going to convert all the variable names to lower case. So that's our first step, is we're going to convert the variable names to lower case. Then we're going to add 5 more steps, also connected with pipes, eventually. So we're going to do these one at a time. So the first thing we're going to do is start with our data set, and we're going to connect it to do another step. Now, hang with me here. I'm going to make the pipe. Now, their pipe is a symbol that does not exist. And so we're going to use symbols on the keyboard and stick them together to make a new symbol. So with the assignment operator, we used the less than and the dash to make an arrow. The pipe is kind of, doesn't seem like anything you've ever seen before. Here, I'm going to grab this. I had a previous student make this for me. This is the pipe. It's hard to see because it's see-through here. This is the pipe. What symbols do we have here? We have a percentage, greater than, percentage. This makes the pipe. This is our connector. So after the name of the data set, we're going to type the pipe. Percentage, greater than, percentage, mush together. That's the pipe. Is craziness, and they chose something crazy so it wasn't on accident that you would type it. Now we can link our data set. We can do something to our data set. So we are going to take our data set and we are going to type into a function. And the first function we're going to type it in is out of what's called the dplyr package. Pliers, what do pliers do? Anyone seen pliers? They're a tool and like your toolbox for, cranking on something. Pliers we're going to use this to wrangle our data set. The D pliers for data dplyrs they're tools for data sets. So we're going to use the dplyr package command that is called rename all. The first thing I'm going to do is rename all of my variables to lower case. There we go. So I'm going to take my data set by its name, df0, and I'm going to pipe it or make it flow into the next step, which is using the dplyr package command rename all and making them to lower case. Notice it's printed out my data set. Does this look like our data set looked before? Really close. The important distinction is now our variable names are all lowercase letters. Just to point out here, it's on my screen, I can see it now. Subject number 10, check out their math quiz. Subject number 10 is the first person in our data set that's missing a math quiz. You see that NA, it's kind of a lighter gray. Show you that. Okay. So the rename function in dplyr renames all your variable names to lowercase. Now we're going to do another step. So every time we have another step, we need another pipe to make the water. We're not having water flow, we're having the data set flow. So first step was to rename to lowercase. Now we're going to do another step, so we need another pipe. And now we are going to create a new variable, which is a version of an existing variable. So once upon a time, we used to like to watch the show called The Simpsons, and on the first of the show, there's like all this nuclear waste going into the pond, and there's this fish that comes up, and the fish has 3 eyes. A third eye is a mutation. The command we're going to use is called mutate. Mutate grows a new not a third eye, but a new variable in your data set. So mutate, and this is in the dplyr package, mutate, M-U-T-A-T-E. Mutate grows a new variable in your data set. In here, we need to say what the name of the variable should be. We're going to call it gender, but I need it to not be identical to the other one. So I'm going to put a capital F on the end to denote that this is going to be the factor version of the gender variable. I know we're out of time. If anyone needs to log off, go. I'm just going to finish this train of thought before I stop the recording, and I'll keep recording the rest of it. And we'll have office hours when? If you can make it? Tomorrow at
7.
7. Okay. So we're going to dplyr mutate to grow a new variable. We're going to call this new variable gender with a capital F, and it's going to be a factor version of the original gender variable. Now I want to pull your attention. I haven't ran it yet, but look down at our data set. We have the gender variable. Notice underneath it, what does it say in really small, faint letters? DBL. And we have the numbers, ones, twos. Now I'm going to run this code chunk. That gender variable did not change. But if I scroll over to the end of my data set, I now have a new variable, which I called gender F. And what do you notice underneath it? It doesn't say DBL.
It's a factor.
It says factor, FCTR. It's really tiny.
What's the benefit of that? Why would we want to change it?
Because now part of this is we can say which number levels go to which text labels. And then when we plot it and make tables and use that variable in models, it will say the labels, not just 1, 2, 3, 1s and 2s. And it's more than trivial. It's like saves your bacon. So right now our numbers are 1s and 2s. 1s and 2s. So when we have 1 and 2, we want to put those together and say the levels currently are 1s and 2s, and we want to label them as female and male. To put the 1 and 2 together, we have to glue those together in kind of like a combined list. To combine them together, we have to put them inside some parentheses together, and in front of it, we have to put a C. Does anyone feel like they're drowning yet? Okay, my kids swim very seriously. They've been on swim teams for 8 years. They can be the state and the region level. And sometimes you just have to dive in the deep end of the swimming pool. And what we're doing today is like diving in the deep end of the swimming pool. So if you're feeling like you're drowning, that's what happens when you dive in, right? So what do you do when you dive in the deep end of the swimming pool? You just try to keep your head above water. That's how you're probably feeling right now, and I know. And there's no way for me to ease you into this. We just have to doggy paddle for a little while and take some deep breaths, and I will guide you along. I know that's how you feel, and I hate that this is where class is ending today with that uncomfortable feeling. So it's okay. If you end like this, we got office hours tomorrow. I'm gonna put up some recording. We'll come back. It's okay. I feel really bad about this, because I'm just saying, wow, I'm throwing so much at you. So the benefit of making the variable a factor is we can say, all right, right now, the levels are 1 and 2. The 1 and 2 have to be in parentheses with this letter C out front. That C stands for the computer word concatenate, which basically means to combine. So right now the levels are a combination of 1s and 2s. That's how we would read it. And I want to change it so that the labels are the combination of female and male. So we've said levels, those are the numbers. Numbers are just bare numbers, 1 and 2. But the labels are text, and so text has to be quoted. So we use the quotes around the word female and male because it's text. We don't put quotes around 1 and 2 because they're numbers. Okay. Now, there's a lot of places to make a mistake here. Spelling, capitalization, parentheses that have to match up, commas between things, and pipes that connect steps. If you're getting an error, I can almost guarantee it's one of those things. Okay. If I did everything correctly and I run this, now if I go to the end of my data set, my new variable gender F is a factor, and look, there's no more 1s and 2s. Instead, we see the word female or the word male. Okay. Now, doing that has the benefits we talked about, but right now, if we look down to the bottom in your environment, we still only have df0. df0 only has 18 variables. That 19th variable is not in df0. We've appended df, the first data set, by putting this at the end, but we need to give it a new name to save it. So we need to assign this to something else. And so we're going to call it df1, shall we? df1. So we're going to take, and to the name df1, we are going to assign it the original data set with the variable names relabeled and a new variable factor version of gender appended or mutated, grown at the end of it. If you have that assignment going on in the code chunk, it does not make anything show up as output. So I'm going to print this down here so we can log off our official end of class. It's, we want to tibble glimpse.
Where were we on 140? That went by pretty fast. What did we do?
It did. And that's why there's a recording going up, and we're gonna have office hours, and we're gonna keep
Okay.
doing this. And yes, I know you guys are just barely keeping your heads above water.
But Dr. Schwartz, so
Yeah.
like, this is what we do for our homework. We play with these things and we just read these instructions and try and fill it out.
Yes, and we will be doing these in class.
Okay.
So this one's not due until we take the test. So we will be able to, I'll make a recording, but we will also be able to go over it in class on Monday when we come back in. On Monday, we'll start class with picking up here. It'll be helpful if you've played with it between now and then, but we will, yes. I've tried to make the instructions informative, but they're not guaranteed to be clear by themselves, especially because this is your first experience with R. Later on in the semester, they'll be easier to understand. Right now, I'm sure they sound like German or Pig Latin or something else. Okay.
Where did we go after 140 then? Where were you just at?
So here on 140, I have saved this as DF1, this DF0, the first data set,
Yeah.
changed to add this new variable. I called it DF1. Then if I scroll down, it's the next code chunk that was empty said, glimpse this new variable, this new data set. Now, we're supposed to do 5 variables, the 5 factors. We've only done just gender so far. But in the glimpse now, and if we look down at the global environment, DF1 has 19 variables. And notice that that last variable is now gender F, which is a factor with the words male and female instead of being a double with numbers 1s and 2s.
Great. Can I see that 160 again? Oh, there it is.
There, it's right there. Tibble is the package, glimpse is the function command.
So how do we save this? Does it save on its own?
Okay, so it does not save on its own. That's important to know. So you need to go up, and now you can use your shortcuts that you use on Word and Excel and PowerPoint. You can do Command or Control S to save, or there's the little floppy disk, which my kids don't know what that is, and you can push that to save, or you can go File, Save As, or Save. The name, you'll notice that the name of the data set is grayed out with an asterisk if there are changes you haven't saved, and once you save them, then it goes white. So notice if I type something, notice how it grays it out, the name, and puts an asterisk at the end. That alerts you that there's something new that hasn't been saved. And then once you save it, it goes bright white again.
So I changed the name of the file. Is that okay?
Yeah, you can leave this R marked down, this RMD file. You can leave it the name that I put on it, or you can change it to whatever you want. Yeah, everyone, when we're done, you're not going to upload this R file. You're going to upload the PDF, but even then, I don't care what it's called.
Tibble.
Tibble, T-I-B-B-L-E, : glimpse.
Can I see 140 again? I'm getting an error, so I can't figure out what I did wrong.
Okay, I'm going to say the end so that no one feels the pressure to stay on. But Melissa, if you want to share your screen, I'll stop sharing mine and you can share yours and we can find the mistake. And it's kind of good to see that process of debugging, because everyone's going to have bugs, I can guarantee it. And they're going to be spelling, capitalization, periods, commas, parentheses that don't match up, and pipes that are missing or too many. Okay, so Melissa, if you want, you can share your screen and we can debug it together.
Do you want to stop recording?
I'm going to keep this part recording,
Okay, just
Yeah.
wondering.
but no pressure to stay on.
Oh. Again, okay, I've got to come in. I'm on a separate computer.
Oh, you're on the separate computer. Okay. And I will share mine again.
That's why sometimes I think, yeah.
Yeah.
Okay, so 160, 159, 160.
So it's probably, if you're having error, it's probably up in the line 140 chunk. So it's df_1. Then we have our assignment arrow, df_0. Then your pipe, your percentage greater than percentage has to be all mushed together.
df underscore
dplyr, rename all to lower. So this is what you can do. See how I've highlighted just part of the code?
Uh-huh.
You can
It
put,
all worked to the very last piece.
okay, so that helps. If you can highlight part and do Control Enter to run just part of it. But let's see, so it's probably here in the dplyr mutate. So dplyr mutate, then our new name, gender F, factor, and factor has to have an open parentheses. And then after the word gender, that has to be all lowercase, a comma. Then levels, L-E-V-E-L-S,
Uh-huh.
equals C. And then after the C, we've got the parentheses. Inside the parentheses is 1, 2, and then there's a comma outside the parentheses.
Yeah.
Okay. And the next line is labels, an equal sign, and then there's a C for combine or concatenate, and then inside those parentheses, female and male are separated with a comma, and at the end you're going to have 3 closed parentheses.
Everything is exactly that way to what I can see. The only thing that might be different is spaces.
Inside the quotes, you can't have extra spaces, but everywhere else, it's pretty okay, usually.
Well, let me try running. a
Melissa,
little
did
bit.
you run it? Because I had the same error because I just didn't
Oh.
run it.
You didn't run it, yeah, so you have to make sure to run this chunk before you run the next.
Oh, that might have been my error. Thank you. Yep, that fixed it.
Sweet.
Oh,
Yep.
that was the problem.
Yeah, it's important that you run your code chunks in the right order. And that's why there's this middle button, run all chunks above, because you can press that and it will start at the top and it'll run them all to make sure one doesn't get skipped.
Well, that's a good button to
And
know.
that's very helpful if you stop working and save it and you come back the next day or next week, you have to start running them all from the top down again. So you just go to where you left off, but make sure you run all the chunks above before you start working again.
Okay, so I think that's all good. Yeah, and it shows up as my next one. So we don't need
I'll put out an announcement. You don't need to do anything with this. I highly suggest you try some of it, but if it doesn't work out, we will pick this up on Monday. You will need to read chapter 3, I believe it is, and do that discussion. And you can work on the non-R parts for chapters 1, 2, and 3. But the R parts, especially at the beginning, if you can't do any of it on your own, that's okay. We will be returning in class to it. This always takes more time than we think.
We'll finish 1, 2, and 3 in class on Monday.
I hope.
Are we supposed to, is 4 due on Monday also?
No, I don't think so. Let's pull up Canvas.
It shows Monday we've got 3 and 4.
Yeah, it's due on
It's
Monday.
3 and 4.
3 and 4.
Yeah, so I would much rather have you spend your time outside of class reading and posting and not banging your head against R. I would rather come back and have us focus on R in class and then do the reading outside of class, because you can, we'll just hit the questions in class on the reading instead of like redoing the entire everything you read in class, unless there's questions on it. But we will really focus on how to do the stuff. This chapter 1 takes longer because it's your first experience in R. It does, and we're doing a ton of stuff.
Hopefully it will make sense at some point.
It's completely a deep end of the pool, doggy paddle, just take a breath experience in chapter 1 with the R.
Okay,
It
so
always is.
So have 1 through 4 done and try to do all the homework for 1 through 4 up to the C section.
Other than the C sections, yes.
Okay.
Maybe I'll put out the announcement now to make that very clear. I don't want anyone spending hours just being like, I don't get it, there's something wrong.